How's the semester going so far?
It's all right. I mean, not too busy so far.
As the now, at least for me, it's felt weird, this like starting off online and going to in-person thing. I don't know, just I feel like I have an online mode and an in-person mode, and switching back and forth between those.
I fully agree with that.
Yeah.
Especially like a lot of my extracurricular meetings have still been it online.
Mm-hmm. So you're kind of like in both modes at the same time. Yeah.
And then because of the capstone, like client meetings, I'm
Still
in person with the team, but zooming in the client.
Oh yeah, those are the weirdest things.
Even weirder.
Do you do it in the room in the QCL that has that like circle thing?
Room. And because last week was a semester meet, we had our team meeting. I was the only one zooming in. Mm-hmm. At least now I know how it feels to be the client.
Yep.
But it was just, it's weird. And the QCL conference room Zoom is even weirder. Have you been in there?
Oh yeah, that. Well, I know that they have that like circle thing. Yeah.
Oh yeah.
Mm-hmm. Yep. So I've been on the other end too. How it's being on the Zoom side while the other people are sitting there. And it's weird how it just randomly switches between people who it's looking at, and yeah, I feel like that half Zoom, half in person meeting style doesn't really work too well.
No, but in some cases, like the client meeting is necessary.
Yeah. So ours would do it. Everybody's on Zoom.
We'll see how it goes today with the half and half system. We're going every 2 weeks to the clients. So if it doesn't work, we'll probably go full Zoom.
There's handouts in the back. The only one of them's new from Friday. Anybody have a particularly good weekend? No? Particularly awful weekend?
Also no.
Oh, okay, just average?
I did the lab before the weekend, so I had a particularly good weekend.
Okay, there we go. Yep. Is the lab, or did I give the right amount of scary lead up, how much work it's going to take, or too much or not enough?
It's funny that the image you upload to your Docker, like on the website, also gets uploaded to GitHub.
So I mean, it depends how you run the exact git commands, but yeah, because when you upload it, it puts it in the Docker container, and how the volumes are linked. The Docker container is, or the volume is linked into the folder, and so if you do like the git add dot, it's going to add everything. Morning, everybody. There are handouts in the back. 3 of them are the same as Friday, and then there's one new one. How's everybody's workload this semester? Does it seem like a average semester for most people? Harder than normal? Easier than normal? Take the silence to mean everybody's average. Shoulder shrugging. Okay. Yeah. I think so. Yeah, I was sort of saying this earlier, but from at least from the professor's perspective, the switching between like the online and in-person classes, I feel like it's weird, kind of disruptive, throws things off. So hopefully it's not been too disruptive for you all, but at least from here on out, we should be mostly normal semester. Okay, we're going to go ahead and get started for our class today. Up on the screen, I have our week 3 folder loaded up. And again, this week we're going over the Sql language. And the Sql language is sort of the standard language for interacting with what's called a relational database management system, or RDBMS. And last time, what we did is we took a quick look at the homework assignments. It's posted in here in the pagila-hw1. And this looks like a folder, but it's actually a submodule. And we know it's a submodule because it has this hash thing associated with it. And inside of this, we're going to take a look at this picture here in detail today. And if you did not pick one of these pictures up, there's a bunch in the back that you can grab. And there's also some leftover cheat sheets on Sql in the back there, which will be helpful for the homework. But yeah, last time we took a quick overview of actually getting connected to the database. We kind of skipped this introductory material that I have and went straight to the technical stuff. Today we're going to spend first 10 minutes or so waking ourselves up with this introductory material, and then we'll hit the technical things, and we will do, in class, I'll solve some of the homework problems, probably about 4 of them, and show you sort of the workflow that you should go through when you're working on those problems. And by the end of today, we'll have all the material covered that you sort of need to know for the homework assignments. Any questions about anything? How is the lab going, or did the lab go for everybody? Homework last week? Thumbs up? Okay. 2 thumbs up, so that's good. Okay. Yeah, so the main takeaway, or the main thing to start with, that it doesn't really matter what the problem is, a database is always the solution. And so this Dilbert comic right here is one of the classics, and it sort of describes this idea that the database is always the solution. You have the pointy-eared boss here, he has some problem, but the engineers over here, they don't even care to hear what the problem actually is. They just start recommending we build a database. And yeah, punchline is, Dilbert says, we like databases. Doesn't matter what the problem is, database is always a solution. And we're starting off talking about this structured query language, SQL, for accessing the database. And you'll notice that I've been pronouncing this as Sql so far whenever I've mentioned it. And here in this comic, it illustrates this idea that I strongly recommend that you don't pronounce it as SQL, because that's sort of a shibboleth for people who pronounce it as SQL are not usually databases people. Maybe like 10% of people who are serious databases people pronounce it SQL, and everybody else pronounces it SQL. So in this comic right here, he says, I think we should build an SQL database, and because it's an and not a, I know he's pronouncing it SQL. If it was a, then I know he was pronouncing it SQL. So a very subtle thing right here is the joke. It's giving away that the pointy-haired boss right here, not a database person, and Dilbert proves it over here by asking about the color of the database. So yeah, you really have to be in the weeds of databases to really get this joke here. So why do we pronounce it SQL? 2 reasons. First, SQL is just 1 syllable less than SQL, so it's faster, and we like efficiency. But the other reason is that it actually used to be SQL like this, so like obviously pronounced SQL, but for various copyright, trademark sort of issues, had to get shortened to SQL. If you're interested in reading the history of all of that, there's a link for you. But the main takeaway again, invented in the 70s, just like the PostgreSQL shell. And so we started last week saw a few of those weird works for like backwards compatibility sort of issues, but there's going to be a lot of weird things. It's not the nicest language to work with, but it's the nicest thing that we have. And again, anytime anybody has questions, feel free to shout out if I am just too distracted looking at the screen or at my laptop here to see your hand raised. My big idea of comparison of SQL to other languages. So most languages that you've used so far, like Python or maybe C, C++, Java, we would call those imperative languages because so imperative is like a command. You are giving commands to the computer. You're micromanaging the computer, specifically telling it how to compute something. And in your data structures course, one of the things that you talked a lot about was sort of efficiency of computations and how if you did different things, different ways, you'd get different efficiency. But one of the nice things about SQL is it's a declarative language. You specify what to do instead of how to do it. And behind the scenes, this Postgres compiler will convert your code, declarative code, your what code, into how code, and provably you will get good performance, sort of like optimal asymptotic runtimes, and also really good constant factors. So we're going to spend a lot of time in this class talking about how this conversion happens and how that's going to affect the type of SQL code that you write. A lot of people who use SQL or use databases use this thing called an object relational mapper, ORM. And these are special libraries that try to hide the SQL interface from the database so that you don't need to know SQL to use the database. And these are really popular among, I would say among applications or companies or developers that have a lot of very junior people working at them, people who maybe for whatever reason don't know how databases work. But as soon as you need to scale things up to like Facebook, Google size certainly, or even much smaller than that, you really need to know like the actual SQL, how things work. And so these ORMs don't really work, aren't good for this. They're not good for scaling. So Twitter famously started with an ORM called Ruby on Rails. It's been more than a decade since they left that, and now they're on Java plus raw SQL because of the bad performance of the scalability issues. Reddit still sort of famously or infamously uses the SQL Alchemy ORM. In the lab homework, all the Python code that was interacting with the database was using the SQL Alchemy ORM. But Reddit also famously has all sorts of downtime issues, and their code is, not even remotely efficient. Any questions so far? High-level things? We're all mostly waking up now. Okay. Okay, we're almost to into the technical stuff, but there's two other categories of databases. One is this NoSQL database. We'll talk in high-level detail about this later on when we talk about the advantages of Postgres. That'll come after we're more familiar with the SQL language. But the high-level idea is there's no standard language for accessing them, like SQL. SQL does not work for NoSQL databases, hence the name. But there's also no guarantees that the data will actually be in the database. The nice thing about these SQL databases is they provide really strong guarantees that once the data is there, it's guaranteed to be there. There's also other types of databases called graph databases that use a language called Sparkle instead of SQL. Totally different. We're not going to talk about those. So this is one of my more favorite websites, just because it's super simple, and I always feel nervous about pronouncing it in class, but I'm just quoting it here, howfuckedismydatabase.com. And so there's a bunch of famous database systems up here. And so we're going to be using Postgres right here, if we click that. And it's wants to know, like, okay, if we have data and we're putting it in these databases, are you going to be okay or not okay? So we're probably okay if we're using Postgres. There's this other thing called Sloaney that people don't really like. So you're probably okay until Saloni breaks here, but this is sort of the best guarantee that any of these have. You're probably okay. Let's try MySQL here. So many of you have seen MySQL before, but MySQL has all sorts of famous bugs inside of it that have caused people to lose their data after sticking the data inside. And so these days, most new companies not using MySQL. Oracle is another famous database that it's pretty solid, but like a single license costs in the order of millions of dollars. So it's really only banks who use this. There are certain laws that require you to use Oracle if you're a bank doing certain things, and that's Oracle's main customer base. Postgres, though, actually supports more features than Oracle. It's more or less like strictly superior. There's a couple things Oracle does that Postgres doesn't, but not many. Let's see. So Microsoft SQL Server. So there's a famous incident where there's a nuclear reactor running Microsoft SQL Server, and that caused the reactor to go down when the database crashed. It's taking us, that's why it's taking long. It's taking us to the actual website about the nuclear reactor going down because Microsoft's database crashed. And even if we press no over here, yeah, I'd rather you doing that than me. And actually, even Microsoft doesn't run Microsoft SQL Server. Just like even Microsoft doesn't run Windows in the cloud, more than 51% of machines in Azure are running Linux. They also prefer to run Postgres instead of SQL Server. So it's just a big summary of why we're using Postgres in the class. Basically, it's better than everything else, and it's free. So for the rest of the class, meaning not just today, but the rest of the semester going forward, we're going to spend about the next 3 weeks on making our SQL code correct. And for each one of those weeks, there's going to be one homework assignment, and then we'll have our midterm at the end of those 3 weeks. The midterm is going to focus only on the SQL and making SQL correct. It's not going to talk about any of the Docker bash stuff that we've done up to this point in the class. But the purpose of the Docker bash stuff is so that we can bring up these databases and get them working and actually interact with the SQL. But I'm not going to quiz you on or test you on like what's the difference between an image and a container, or what's the incantation to make something happen. It'll all be on the SQL things from here forward. And then after that, the last half of the class, we'll be making mostly SQL, but a few other things really fast. And so understanding exactly what's happening under the hood of this Postgres system and comparing it to some of these other systems and seeing why Postgres is better. Any questions about any of that? Okay, then on to the technical stuff. So again, your midterm and the homeworks, all about how writing SQL queries that are correct for these next 3 weeks. And this website right here, PostgreSQL tutorial, is the one that you're going to want to reference for if there's something in lecture that you didn't fully understand, or for the homeworks, getting the homeworks completed. There will be things, let's see. In class, we're not going to cover everything that you will need to know for the homework assignments. We will cover all the general principles, but there will be things that you'll have to look up either here or using the different cheat sheets or just Google in order to get things correct. Okay, so switching over to the terminal. I'm in my Pagila homework folder, which last time on Friday we saw how to clone from GitHub and get running. And right now, if I run docker ps, you'll see that I have this container running. Let's go ahead and bring it down so we can get a fresh one. Up -d. Now it's running in the background. And now if I want to connect to the container and run commands in the database, we had 2 options of how to do that. Docker compose exec pg. PG right here because in the docker compose.yaml file, the service is called PG right here on line 4, and whatever goes after the exec is the name of the service. And then I can type the name of the command that I want to run. pSql is the name of the command that connects to the Postgres database. And then down here I can do something like \d, which gets me the list of all of the relations that I have in my database. So this environment right here that I'm in is called the pager environment. That lets me scroll through things. Press Q to get out of the pager environment, Control D to get out of pSql here, up arrow to get back to that previous command. And another way that I can get into the containers, instead of connecting to pSql directly, I can connect to bash. And then here I can run my normal bash commands. And one of those normal bash commands is pSql. And I can connect this way, running the same commands like this. And we get the same results. Either way of connecting is fine. This bash way is a little bit more versatile because then you'll have the flexibility of running non-SQL commands if you need to. Any questions at this point? Yes.
So if I run it the bash way, it works, but if I run bash and then right after that, it's really like pSql.
Saying if you do this?
Yeah.
Okay, yeah, so what happens when we do this? What exactly is going on? The answer is that when you do docker compose exec pg bash, whatever comes after is parameters to the thing that comes before. And so here, this is equivalent to in the container environment doing something like bash pSql like this. And this is not a valid bash command. Bash expects the thing afterward to be a shell script. This is not a shell script, and so that's why we're getting these particular errors right here. So this command doesn't work. This command does work. This command does work. Did that answer your question? Your question. Any other questions at this point? Yes. Yeah, so the question is, like, if this is a Postgres container, how can we run bash? And the answer is that, so we could take a look at the Docker file to see exactly what's going on. But so here, this Docker file is built from a Postgres image, version 12. Postgres happens to be at version 14 right now, so we could change this to 14. But I don't think anything would break, but we'll just keep it at 12 to make things not break. But everything in here is just a normal Linux machine. I believe I can't think of the name of the distro that it's based off of right now. We can install all of the different commands using apt-get, update, and install. So it's a flavor of Debian because we have apt-get available. And one of the things that just comes installed on this machine is Postgres, or sorry, yes, Postgres is one of the things, but bash is also one of the things that comes installed on this machine. And so that's why we have access to bash. The vast majority of containers will have, they will all have some sort of shell available that you can use. The vast majority will have bash as something that you can log into right here and get to run. I'm not sure if that's answering your question. Okay, so last time we talked a little bit about the homework is structured the same way that a typical Postgres project would be structured. And here we have a SQL folder, and if we type ls SQL, we can see there's a bunch of different files ending in .sql. And each of these files is going to correspond to one of the problems that you have in your homework assignments. You can see that there's 17 of these files, and normally I would number things starting at 0 instead of starting at 1, but SQL back in the day in the 70s, computer scientists were still divided on whether 0 or 1 is the first number, and the SQL people believed that 1 was the first number, and so that continues to be the case in SQL implementations, and so that's why we're starting at 1, because we'll follow the SQL convention here instead of the Python or C convention that 0 is the first number. So 17 problems starting at 1. And then for each of these problems, let's go ahead and open up the problem. So vim sql/o1.sql. At the top, it has a comment explaining what you're supposed to do for the problem. And then :tab E. So I'm going to open up another file down here in a second tab. And there's a folder, type ls again to get the folders. So SQL here is a folder, results is a folder, and expected is a folder. Expected contains the location of what the sort of correct output is for any of these test cases. So I'll do tab E, expected/o1. And then the extension here is .out, standing for output. This is the output of a correct implementation of the o1.sql down here. And we need to write a SQL command that is going to give us this output over here. And the sort of semantics of this output is defined by this problem right here. So it says display the first and last name of each actor in a single column in uppercase letters. Up here, let's connect back to pSQL for a second, and we'll do \d. Recall that \d lists all of the relations in the database. If I want to get information about a specific relation, it's \d, then the name of the relation. And let's zoom out just for a second so that things fit sort of nicely. And the important things, again, are the column name over here and the column type. And back over on our, so I gave you all printouts of this today, but on this diagram of sort of the format of the database down here, we have the actor. You can see that there's these 4 things listed under this box, this table over here, and those correspond to the 4 columns over here. So in order to get the first and last name of each actor, we can do select first name, comma, last name from actor, like this. And this gives me the first and last name of all the actors. In this case, it wants it as a single column, though. And so instead of doing a comma between the columns, we'll do the string concatenation, which again in SQL is the double vertical bar, not the plus sign. Some dialects of SQL, like SQLite, if you've used that before, would support the plus sign. But the double vertical bar is the sort of ANSI standard that everybody supports. And it's also the only thing that Postgres supports. Maybe one of the annoying things for newcomers to Postgres is that Postgres is a very ANSI standard compliant with its SQL language. And so there's not as many nice features maybe or syntactic sugar as other languages have. But the good thing is that whatever you write in Postgres is probably going to work no matter what database system you run, if you have to translate your code to a different database. So we concatenate those things together, and we notice that they're not the same format as our output over here. That the we want is the space between the different words. So let's Q out of that, up arrow back over here, and add a space between like that. Now we're getting the space between words. It's specifically asking that the column be named actor name. And recall from last time that in order to name a column, you use the as keyword. And it doesn't matter whether it's uppercase or lowercase. SQL is case insensitive. But in order to have a column name with a space in it, you use the double quotation marks, actor space name like this, hit enter. Now we're getting closer. We have the column named correctly. All of the particular rows are formatted correctly. We just have to do the last part about sorting the results alphabetically. So Q up here, up arrow down here. In order to sort in SQL, there's an order by clause, order by, and then we have to type the name of the column that we want to order by. This is going to be one of the areas where people make the maybe have the most frustrations with the homework assignment is getting the right order by on all of the things. And here we have a number of different choices about what we could order by. One choice is that we could do something like order by last name, like this. And this is a reasonable way to sort things, to order things, ordering by last name. But if we look at the actual output over here, we can see that that's not actually what it's asking for. It's not asking for us to order by last name. And so let's quit out of that. And so we'll try ordering by first name like that. And now we're doing a lot better. Things seem to be matching what we have down here. And so at this point, I'm going to, I've been just working with pSQL a lot, interactively testing things out, refining my answer until we get to something that I think is going to be correct. And then once I have something that I like or I want to really test out, see if it's correct, I'll put it down here and I can just copy and paste this like that down there. And now it's ready to actually be tested against. Question?
Can you go back to the output from the last command?
Yes. Yes. So yes, if you're paying particularly close attention at this point, you can see that some lines are not exactly, it's not exactly the correct output. And so that's intentional at this point. This is not a fully correct solution yet, but we're going to run the test cases and see how, what happens when we have an almost correct but not correct solution. So good observation, but not quite there yet. Joey?
If you had replaced the single quotes with double quotes, would it work the same way?
Yeah, so good question. Quotation marks in SQL, and especially in Postgres, are a particularly finicky thing. That over here, we have what in programming languages terms, this part over here is called a value in programming languages terms, that it's like an actual string, an actual, like, it's the actual data over here to the left. These are the column names that we're working with. This is a literal. And so the column names are sort of like variables from traditional programming languages that we're combining together. But this over here is a value. And anytime you have a value, so basically anytime you have anything that's to the right of a select, you can only use single quotation marks in this location. Single quotation marks is the only thing that's allowed. To the right of an as, we have an identifier, not a value. And identifiers always use double quotation marks, never single quotation marks. So here, we could replace that with single quotation marks, and we'll get an error saying that that's not allowed because it's just not a valid spot to use the single quotation marks. We're getting that syntax error. If over here we try to put double quotation marks around the space, we'd get a similar error saying column space does not exist. That anytime you have something around, double quotation marks around something, it means that it has to refer to sort of like a variable name. So in this location, the only sort of names that are available are column names. So I would be allowed to put these in single quotation marks and this in double quotation marks. That's okay because this right here is a column name, so that'll still work. But double quotation marks always refers to something that is in the schema of your table. So either a column name or the actual table name. You can see up here, it's putting that in double quotation marks because it has this public dot special thing in front of it. The table name over here, we could put from actor in double quotation marks, that would be okay. But yes, single quotation marks, double quotation marks, different thing, different meaning in SQL, and so you have to be careful about which one you're using. Good question. Any other questions so far? Yes.
Can you use the dollar sign somewhere around there, right?
Oh, yes, and then last time we also saw that instead of single quotation marks, you're allowed to use dollar signs as quotation marks. So the double dollar sign right here is equivalent to this quotation mark and putting a space in between. And we can also name our quotation marks doing something like my quote like this. And this is just all three of these lines are referring to the exact same thing, just different syntax for the same thing. There's no equivalent of dollar sign for the double quotation marks. Okay, so we have a passable, reasonable attempt for this first homework problem written out here. But if you're paying close attention, you might have noticed a couple of these lines aren't exactly in order. So we're going to take a look now at exactly how to test out your code and how to figure out what exactly are the correct parts and the incorrect parts about it. And so up here notice that I'm in the container right now. Control D out of pSql inside bash right now. I can type ls. And there's this checkanswers.sh script. If I open that up in Vim, checkanswers.sh, you'll see that it's a normal shell script using a lot of the same sort of techniques that we saw before. But basically, it's going through each one of these problems in the SQL star right here and running some code to see if it's correct or not. Let's go ahead and run this, doing /checkanswers.sh, and it'll put out a little message like this for each one of our problems. And in this case, they are all failing. Numbers 2 and on are failing because we haven't even looked at those yet. There's no output. But number 1 is failing because the output is not correct. If we want to look at the actual output that we're receiving, then there is a folder. The results folder, results right here, shows where the actual output of your program. So down here, I'm going to go :tab-e results /01.out like this. And so this gives us the actual output of our program. And you'll notice that what we have right here is the same stuff that we were getting up above when we were running this command directly in pSql. Are there any questions at this point? Okay, so we can sort of like manually go through and try to find like what exactly is all of the differences here. And in this case, it's not too hard maybe to do that. We can, there we go. So GT, G capital T to switch back and forth between these windows. We can see that basically it looks like all of these first names look good, but the last names over here are not coming in the right order for whatever reason. And whenever we have an order by clause, if there's something that matches, like say the same first name but different last names, then SQL is free to give us any arbitrary order for the final results. So here, the first name for both of these two people is Adam. So Adam must come before Al because just alphabetical order. But now we have Hopper and Grant, and the SQL database is free to make whatever choice it wants to put these in alphabetical order. And so we can fix that by coming over here, $, taking me to the end of the line, insert, comma, first name, last name like this. And now it's going to first order by the first name and then order by the last name. And so now when we have a situation like Adam Hopper, Adam Grant, it's going to make sure that the last names are also alphabetically ordered. I'm going to come up here, rerun my check answers command, /checkanswers. That's going to rerun all of my SQL commands. Down here in the bottom Vim window, you notice that none of the output down here changed at all in this window down here. I've changed the file right here, but the output has not changed. in order to cause this output to change, in order to see the new results, I'm going to type :E in Vim, :E down in the bottom. E stands for edit, and it means reopen the file. I'll hit enter, and once I do this, I can't go back. So pay close attention to how things change. 3, 2, 1, enter. And now all of the names have changed so that they are first ordered alphabetically by the first name and then ordered alphabetically by the second name. So that seems like things are getting a little bit closer. If I switch back and forth between these two tabs, things are yeah, getting a little bit closer, but still not exactly matching for some reason. And we know if we look up here at the top, right here, this first line still telling us that we're failing because the outputs are not exactly the same. Again, down here, I can run through sort of just back and forth, and we can try to find exactly what the specific lines are that are different between the two files. And we can see that the problem is related to Al Garland here. That Al Garland in this output is put at the end of all the Alberts, Alex, but in this one, he's put at the very beginning. What's happening is that this still isn't the correct order by. So I just copied and pasted this line, YY copies a line, then P to paste it. And then let's comment this out. The dash dash is the SQL comment. So we're commenting this out just so that we can continue to refer to it and see what the difference is between this one up here and this one down here. And now down on line 7, I will move over, do it faster. I'll do FF to go to the next F in the line. And then I want to delete both of these two things. I'll do C3W to delete the next 3 words. So it deleted first name, the comma, and the last name, and put me in insert mode. And what I want to order by actually is not first name, comma, last name, but this whole thing right here. And so order by actor name like this. And save that, up here, up arrow, rerun that, up, and now we see that it is in fact actually passing. So a lot of going back and forth between the output and the expected output to figure out what is the exact difference, refining my command until I get something that's actually passing. Yes?
I'm not sure if you said the difference between sorting by first name and last name versus actor name.
Yeah, it's a great question. The question is that what exactly, why is there a difference between doing first name, last name, and then sorting by this? The answer is exactly, it's related to spaces. That here, if when we sort just by the first name first, then Al is alphabetically before Alan because Al has nothing after it. And so Al gets put before Alan. But when we sort by the entire name at once, Al gets put at the end because if you recall, alphabetical sorting is not actually alphabetical, it's ASCII-betical, and the space happens to have a larger ASCII value than any character, and so it gets put at the end of the list here. So it's, yeah, very subtle distinction, and based on the, just what the problem is asking for, in terms of the English up here, either one of these would be an acceptable thing. But based on what the actual output is asking for in this more technical, formal sense, then only this second one works down here. One of the, so in the past, these getting the right order by is one of the trickier things for students to do on all of these problems. And getting these order bys correct for actual real world test cases turns out to be also in the real world one of the trickiest things to do. And we need these order bys to be actually correct in real world test cases because we need what's called deterministic output, that every time I run this code, it's going to give me the exact same results no matter what machine I'm on in order for the test cases to be effective. And yeah, so if it seems like you're spending a lot of time just fighting this order by, that's normal. Yes.
Could you do like, could you order by like a string concatenation thing?
Yeah, so the question is like, here I have an actual column name over here. Could I do something different? So I'm gonna do di quotation marks, delete those quotation marks, and I'll cheat for a second, highlight all of this, and just paste it in Vim like that. And you can order by arbitrary sort of commands over here on the right-hand side. That's a perfectly fine thing to do. In order to illustrate this, up here, let's reopen pSQL. And then down here. So notice at this point, what I want to do is I want to copy and paste this command from down here up to here and hit enter. But if I do that, I get this syntax error because when I copy and paste down here, I have all this weird space right here because of my numbering on SQL. Very often when I'm working in SQL, I choose to remove the line numberings from Vim so that it's easier to copy and paste between SQL down here and pSQL up here, or between Vim down here and pSQL up here. And the way to remove line numberings is to do : set no number. And that removes the line numbering. So now when I copy and paste, there's no like weird numbers and spaces. And up there, hit enter, it actually copies it and pastes it. And this gives us the exact same results as the previous command did. And in particular, you'll notice that Al Garland is at the end of all the other AL names. But yeah, you can even have like arbitrary order by things over here that don't line up to any column sort of information at all. Like, so we have no column anywhere that is just a space in front of a last name, but that would be a perfectly fine thing to do up here. Maybe a semantically weird thing to do, but syntactically okay thing to do. Was that answering the question that you're asking? Good questions. Any other questions at this point? Yes.
Quick question about capitalization. So if any of the query words are capitalized with the result, then or like, is there a reason why our output is capitalized that add is capitalized? Like, if select is capitalized, or what happens?
Good question. So question is, when we run all these commands, all this output down here is capitalized. And what exactly is the reason for that? The sort of fundamental reason is that just actually in the database, all the information is capitalized. And we could do something like lower apply to all of this to convert it all to lowercase. And now it's all in lowercase. The fact that the as right here is capitalized doesn't actually affect anything. Everything's still capitalized. It's just the fact that actually, like, physically on the hard drive, the information is saved with capital letters. These, yeah, one of the cheat sheets that you have is a big list of like string manipulation functions in Postgres. And I'm not going to go over all of those functions, but the first 4 of these problems are specifically asking you to do different string manipulation things. And so you have to look on that cheat sheet or Google around to figure out how to do that. Yeah, the first 4 problems are basically just, they're going to follow this same format right here, but you'll have to do some sort of string manipulation, like concatenating things together, or uppercasing or lowercasing things, or different things like that.
So regardless of the capitalization of the SQL query, like it's just going to output unless you manipulate somehow the way that it's being used.
Exactly. SQL is case insensitive, so it doesn't matter how you capitalize things. In SQL, it's 100% equivalent to non-capitalized things. Let's see, so this right here is a particularly ugly version of the SQL code. If I was being a little bit more careful, I would probably do something like this. let's do the actual correct one. This would be a more pretty solution. Yeah, there's a nicer formatted solution, entirely equivalent, but this has better white spacing and better capitalization. Any other questions on this first problem or the sort of workflow that we did to check the answer? Okay, then I want us to take a look at problem number 5 next. Sql/o5.sql. This is going to introduce something called an aggregation function. And so our problem here, count the total number of G-rated films. So here, so first the hint is, let's look at the film table in the rating column. So let's do \d film to see all the columns. And there's a lot of columns in this table. We could also look over here to see at the little database diagram over here, finding the film. Okay, here's the film. There's a whole bunch of different columns in this table, and there's this rating column right here. Good way to get started on any of these problems is just to do a simple select query of something like select rating from film like this, just to get a sense of what's kind of in the data here. And we can see there's, so this rating refers to the like G, PG, R, that kind of thing about movies. And what we want to do is, or the first thing that we're going to do is we want to count like how many different types of movies are there with these different ratings. And actually, maybe even before that, we want to just count how many movies are there in total. So let's do a select count star from film like this. And this will tell me the total number of rows in this film table. In this case, it's only 1,000 rows in this table. Previously, last time, I said that this is bad. Select star from film is bad. This is something that you never want to do. So, don't do this. Don't select star from film. There's a lot of reasons why this is bad. But select count star from film, this is good. This is good. This is the right way to count the total number of rows in this table. So it's a little bit confusing here that the star here is good and the star here is bad. But this is the right way to do a count. And what we actually wanted to do, though, was count not the total number of rows, but the total number of rows for each rating. And so if I do count star comma rating like this, this is sort of at an intuitive level what I might want to have happen, that it'll list all of the ratings and give me a total for each one of these ratings. This is not the right syntax, though. There are other SQL dialects, MySQL, SQLite in particular, that support this sort of shorthand notation. But in order to count everything that matches on a particular column, we have to add this group by clause. So up arrow, get back to here, and then group by rating like this. And now it shows these different ratings. There are only 5 different ratings in the data set, and the total number of movies corresponding to each rating like this. This function over here that sort of reduces the total number of rows in a table is called an aggregate function. The count function is probably the most commonly used one, but there are other aggregate functions as well. And anytime you have an aggregate function, if you have other columns that are being selected, you also have to have group by, and the column list over here must match exactly the column list over here. The order doesn't matter. I could change this to be rating comma count star. That's probably, for like a report, a nicer way to do this. But yeah, this is the super common pattern. If you want to count the total number of times a different column appears, if it appears multiple times, then you add it to the select columns over here and also add the group by over here. Any questions about that? Yeah.
What if you didn't put the group by?
Yeah, without the group by, it's just a syntax error. It's going to complain saying this film.rating. What this dot means is that the thing to the left of the dot is the table name. So film.rating is table film column rating must appear in the group by clause or be used in an aggregate function. Here, rating is not used in an aggregate function, and so it's must appear in the group by clause, like that. So it's sort of, yeah, in some sense like meaningless. This is not providing any extra information to the command. It's just required for syntax. Here, what the problem is specifically asking is not for all of the different ratings, though, but just for one of the ratings, and in particular, how many G-rated films are there. And so anytime we want to filter the rows, only return a certain subset of rows, then another clause that we'll add is the where clause, where rating equals G, like that. Oops, and that should go before the group by. So the where filters out any unneeded columns, and then the group by makes it work with the aggregate function. And so this should be a, or our hypothesis is that this is a correct solution to this problem down here. So let's go ahead, now that we've created it, copy and paste it down here, escape : WQ. One of the common sort of errors that people run into a lot is you run the check answers command from not inside the container down here below. I'm not inside the container right now. And so you get all these weird error messages saying things like roll user test does not exist. And you want to actually run this command from the bash inside the container /check answers up here. And there we go. Let's see, it looks like, so the first one passed, number 5 here has failed. Let's try to figure out why did number 5 fail. So let's open up the Sql again. Let's open up the, we'll do results and open up the expected. And okay, so the, here we got the, we're basically doing the right thing, but just the columns, we added one column that we didn't need to have. We only needed the count over here. So over here, instead of doing select rating comma count star, let's change that to just count star. So it's only the ratings we want. Save that up here, rerun it. And now we get pass 1, pass 5. So again, for these outputs, it's literally just like checking character by character that the results folder matches the expected folder. And so you have to do some maybe trivial modifications to the Sql command just to make the output correctly formatted. Yes? Yeah, the question is, so now that we have this where clause here, could we take out the group by? And I think we probably could actually. So let's save that, come up here, rerun it. Yep, and it's still passing. So in general, for all of these SQL queries, there are many equivalent queries that you can write. And there's, yeah, as long as you're getting the right answer and you feel like you understand why you're getting the right answer, that's good enough. There's no sort of like style grading on is your answer code golfed enough to get the shortest answer possible or the most beautiful answer possible or anything like that. That's a great observation. Any other questions? Yeah.
When do you use where versus having?
Good question. So where versus having. Where versus, so where happens before a group by, having happens after a group by. On all the problems on the homework, you only need to use where. having is a new addition to the SQL standard. There's nothing that requires, like ever, there's never anything that requires having. It's just a sort of a syntactic sugar over a couple of other things. And yeah, so I don't know, there might be some situations in the homeworks that the answer could be simplified using having. I don't think I've ever in my life used having, though, in an actual SQL query, just using where. Let's see, so these, the group by, the aggregate functions will take you up to problem 8 in the homework. And then let's take a look at problem 8. So typically, students, I think, do pretty well on all the different string manipulation stuff and the aggregate functions and the group by. It's all involving just a single table, and so it's relatively easy to get your head wrapped around. The join command involves combining multiple tables together, and this is where things start to get a little bit tricky. All of the problems in this first homework only use what's called an inner join. And then the next week's homework, turns out there's 5 or 6 different types of joins, depending on how you count them. The next homework is going to involve using all of those different types of joins. So in order to illustrate exactly what these joins are, so back over here, there is a file, createtables.sql that that we'll use to see exactly what's going on with the different join types. So yeah, if you want to follow along, you'll need to download this file right here onto the Lambda server. A good way to do that, if you just click the file and then click raw, then you can copy and paste this line. Then over here, doing something like wget, then the URL to that file, we'll download that file for you. Let's see, I already have it, so it gave me this, this extra with a .1 right here. So let's go ahead and delete that. In order to get this file loaded up into, well, I guess, yeah, first let's just take a quick look at what that file is. So create tables. It has 2 create table commands. These commands are copied from the, here it is. All of these joins right here use these 2 tables as their working examples. So I'm going to explain joins using these same tables, but using a slightly different explanation than how they explain it over here. And so in these 2 tables, there's just 2 columns, A, fruit A, B, fruit B, and they're inserting some values into those tables, and that's all that this file contains. In order to actually run this file, get it uploaded into the database, let's go ahead and reload bash up here. And then here, instead of, one thing I could do is I could type pSQL and then I could copy and paste all these commands, but that's annoying. I don't like copying and pasting. A better thing to do is to do input redirection. So pSQL takes whatever gets passed in as standard input and passes it directly to the database. So rather than typing things in using the keyboard with standard input, I'll use the > sign to send a file through standard input. And the file that I'll send is the createtables.sql. And here's our output, just running those 4 create tables and those insert commands. And so now when I run pSQL, I can do something like select star from basket A, and it shows me all the contents of basket A right here. Any questions about how I loaded that into the database? Select star from basket B, and there's everything in basket B. So I'm going to swap the verticalness of these terminals for a second. For the next command that I'm going to run, what I want to do, the first thing that I'm going to do is what's called a cross join between basket A and B. And in a cross join, what we do is we take every one of these rows and duplicate it for every one of these rows down here. So I'll run it, and then we'll see what's going on. So I'll do a select star from basket A, comma, basket B. So this is the new syntax that we're introducing right here. Previously, we only saw commas to the left of the from, where it was listing different columns. Now we're seeing a comma to the right of the from. So there's a comma right here, and it's listing different tables. There's two different tables right here. This comma right here is what does the cross join. So comma to the right of the from is a cross join. And I'll hit enter, and this is the results of the cross join. You can see that the number of columns has increased, and in particular, A and fruit A, these were the columns from the basket A table, and B and fruit B, these are the columns from the basket B table over here. And so we get all of the columns from all of the tables listed to the right of the from. We have a lot of rows down here, though. Both tables previously had 4 rows, and so we get 16 rows down here. And a cross join, total number of rows is the product of the number of rows of each base table. So each base table had 4. 4 times 4 is 16. That's why we have 16 rows down here. The reason why we get this many, again, is because for each one of the rows in the basket A table, we had, so example, one apple. We'll repeat that row once for every one of the rows in the basket B table. 4 rows down here, orange, apple, watermelon, pear, orange, apple, watermelon, pear, repeated 4 times. So 4, 4, 4, 4. It's called a cross join because it's sort of like the cross product between 2 tables, just everything matched with everything else.
So why are all the fruits in table A grouped together?
Yeah, great question. The question is that it looks like things are sort of ordered here where we have like 4 apples, then 4 oranges, then 4 bananas, 4 cucumbers. And why is that the case? The answer is that anytime you have a select statement with no order by, then you might sometimes seem like you're getting like logical orderings of things, but you're not. It's the results are what we call non-deterministically ordered, which means Postgres or whatever database server you're using is allowed to order those results in whatever way makes things more efficient for it. And here in, after we're done with the correct SQL portion of this course, we're going to talk about like how does Postgres make things more efficient. And so we'll see the underlying algorithm that it's using here that happens to be causing it to come out in this order. But if we had different data loaded, or if the data was structured differently on the disk, or any number of things changed, then this order would change differently as well. And so you can only rely on the order being the way it is if you actually specify an order clause. So here, basically what the ordering is order by A, comma, B. That gives us the same ordering that we had before. If we change that to B, comma, A, that gives us the different ordering where now things are grouped sort of on the basket B fruits and not grouped on the A fruits. So yeah, short answer is no semantic meaning to what the ordering is, just happened to look nice. Good question. Any other questions about the cross join? Okay.
What's like an example where you would want to use it?
Good question. The question is like, why would you want to use the cross join? The answer is I have never in practice wanted to use the cross join, but all the other joins are equivalent to a cross join plus a where clause. And so here we have this cross join, and the reason we're introducing this cross join is to understand what is an inner join look like. The inner join is the sort of join that you'll need on the homework assignments. And then on Wednesday, we'll talk about the other different types of joins, but they're all basically just cross join minus certain stuff. And so here, the certain stuff to reduce a cross join to an inner join is we find all of the rows where 2 things match each other. So I'm going to do, let's shift this up so we can see it a little bit better, see the whole line of the SQL command. Here's the original cross join, and I'm going to change this, adding a where clause, where fruit underscore A equals fruit underscore B, like this. And that should go, we don't need the order by, so I'll just delete the order by, but the order by always comes last. So since I moved my thing over here, I guess I'll add it again, A comma B. Like that. And so there's only these two rows where the fruits actually match each other. And it turns out that this is a particularly common thing that you want to do. So it has a nice syntactic sugar for doing it called the inner join, where you say select star from, doesn't matter which one of these you list first, but we'll say basket underscore A, and then join basket underscore B on fruit A equals fruit B. These two commands right here, totally equivalent. I guess technically not, since I didn't add the order by A comma B, like that. Now they're totally equivalent. The stuff that goes in the parentheses right here is equivalent to the stuff that comes after the where clause over here. Most of the time on an inner join, you'll see equalities happening over here, but there will be times in this course where we'll see like inequalities or not equals or things that are more complicated than just equalities. And so when you have that, going back to the inner join and thinking about like what is this syntactic sugar actually for, then yeah. If ever you're confused about a join, the way to understand the join is to desugar it, go back to the cross join, understand the cross join. Here, so we have basket A join basket B. The order doesn't matter. So the join operation here is commutative. You get the same results no matter what you get, what order you put them in. And I guess maybe you can see that the order of the columns changed, so you get the same results up to column ordering. Any questions about that? Yeah, Julie. The parentheses right here refer to all of the things that come to the right of the where clause in the cross join. So this is the condition that we were doing an inner join on. We do the cross join, and then we only select rows matching this condition right here, where the fruit on both of these columns happens to be the same. On this homework assignment in the for the Pagila database, I'm going to switch my screen over here so we can look at the database. There we go. You'll be having to join different tables together in different ways, but anytime you have to join two tables together on this homework assignment only, you'll be using an inner join, and the join will happen between two columns that share the same name in the same table. So you can see lots of examples where that's happening, like film actor and actor here both have an actor ID. So you're allowed to do a join on the actor ID. Let's go ahead and go to problem number 8 now, and we will solve that problem. So vim sql/08.sql. So use a join to display the first and last names as well as the address of each staff member. Use the table staff and address. So coming back over here, we have the table staff, the table address. We have address ID right here. Under staff, we have address ID right here. So those will be the columns that we want to join on. Back up here, we'll do select. Select. It says first and last names as well as the address. So let's see, first name, that looks like first underscore name. So first underscore name, last underscore name. Those are the things we need from the staff table. From the address table up here, there is address. That's what we'll want. Address from. And then, whoops, I'm in Bash right now, into pSQL. Select first name, last name, address from. Hit enter. And we want from the staff table, join on address, and then I can say on staff dot address ID equals address dot address ID. Again, the thing to the left of the dot is the name of the table. The thing to the right of the dot is the name of the column. In this case, if I just type the column name, address ID, then it would be ambiguous which table I'm referring to. Is it referring to the staff address ID or the address ID? And so I need to add the dot in front of it in order to let it know which table it's getting that particular column from. And we'll hit enter like that. And we get that there are two people. There's actually only 2 staff members in this database. So here are the 2 staff members, and here are their addresses. And then if we added the order by last name like that, okay, now it's ordered correctly. Now I think I might have a good solution to this problem. So let's copy that. G down here. Paste that, escape, W. Up here, Control D, back to the terminal, / check answers, run it. This is problem number 8. We see that we're still failing. Let's go check out the difference between our expected and our results. And you can see that the difference is very minor. Just in the expected, I put street address, named the column street address for whatever reason. So over here, we need to change address as street address like that to get the column name fixed. And then up here, run it. And now you can see that it's passing problem 8 right here. Another, let's see. So this is a little bit of an annoying syntax right here, doing staff.address_id equals address.address ID. Anytime that the column names are the same on both of the tables, there's a nice syntactic sugar that we can use. So I'll comment that out and add join address using address ID. So using address ID is equivalent to on and then a condition. Using column name is equivalent to on column equals column name for all the tables. So those 2 things are the same. Come up here, run it, still passing. For all of the problems on this first homework assignment, you'll be able to use the using like this with column over here. Just getting those columns correct. Any questions about that? Joy?
Do you have to have the address ID in parentheses after you
I believe parentheses are required, but let's check. Oh, so we're getting an error message now saying, yeah, doesn't know what's going on. So yeah, the parentheses are required. Good question. Any other questions? This one? Yes.
like errors where are not like very informative. So is there a way to know what kind of structure?
Yeah, it's a good question. So the syntax errors are not super informative. Is there a way to understand them better? The only answer I have to that is copy and paste it into Google, and you'll get a Stack Overflow link that explains what it actually means. Yeah, I think the syntax errors are informative, but there's always a huge gap between like people experienced with the language thinking the syntax errors are informative and people just starting out with it. Yeah, so that's everything that you need to know for this this first homework assignment. On Wednesday, we'll be going over more join types yeah. If anybody has more questions, I'm happy to stick it around now and answer them. Otherwise, I have my office hours at 1 and happy to see anybody there to get questions answered.